Okay, so for the final objective, objective 3 in this lesson, we're talking about solving a system of linear inequalities, and we're going to do this also by graphing. So in the picture here, you've got a couple of things happening. First of all, you've got yourself some colored pencils, right? And each one of the colored pencils are of different sizes, so their length, they're not equal to each other, so we're talking about something being unequal, an inequality. The next thing is if you were to graph yourself a linear equation, a linear inequality in two variables, x and y, you remember you do something like what's on the bottom of this picture. You have to shade a portion. And for shading it, we need ourselves some colored pencils. So why don't you pause yourself right here, go to wherever you keep your colored pencils or crayons or whatever, get yourself some of those to go with that graph paper that you did the first part of this lesson with, because we're going to need them both. Okay, colored pencils, some graph paper. Let's go. So before we do a system of linear inequalities in two variables, let's just graph one of them. So in exercise 8, let's graph the inequality y is greater than 1/2 x minus 3. Okay, so whenever you go to graph this, first of all, you graph it like you would graph a line y equals 1/2 x minus 3. But since it is greater than and not equal to, instead of making it a solid line, we're going to make it a dashed line. Okay? So I still graph it the same way. I still start at -3 for the y-intercept, so put a dot. And now I'm going to use the slope 1/2. So I'll go up 1, right 2, up 1, right 2, so on. Right there. How about I go in the other direction, down 1, left 2, a couple of points that way as well. Okay, instead of this being a solid line, I'm just going to dash this thing in here. Okay. Voila, that looks fantastic. Okay, the other part is that this is not complete until you shade a portion of the plane. I'm going to switch colors here, and you've got a couple of ways to do this. If your y is by itself, it's very easy to figure out what part of your plane to shade, because y is the actual line itself. And I want to graph greater than. Y is greater than, so here is the line. Y is greater than that. So my y-coordinate that I'm looking for is bigger than this line. This means I'm going to shade up. Okay? Now, here's a second method. If this one is not working for you, just choose a test point. The best test point is always the origin, as long as your line doesn't go through that point. If it does, you have to pick something else. Okay? Because it would, of course, satisfy it if it was on the line. So let's stick in 0, 0 for x and for y, and see if it turns out to be a true statement. If it's a true statement, that's the part that I shade. If it's a false statement, I shade the other part. Okay? So let's go ahead and stick in 0 for y is greater than, I'm going to take 1/2 of 0 minus 3. Half of 0? Well, that's still 0. So I get 0 is greater than -3. Is 0 bigger than -3? Sure is. So that's the portion of the graph that I shade, the one that contains the point 0, 0. Okay? So either one of those methods, whichever one makes the most sense to you. So now whenever I go to solve a system of linear inequalities, I would have more than one of those inequalities with all of its shading and see where they intersect. Not just the point of intersection of the two lines, but where the colors intersect as well. So a system of linear inequalities is a collection of two or more inequalities with the same variables. Here we're talking about x's and y's. And the solution to a system of linear inequalities is not a single point. It's a whole entire region. It's a set of ordered pairs, x, y, that satisfy both of the inequalities if there's two of them. All three of them if there's three, and so on. So really what we're doing is we're talking about, if I look at this system right here, the red line is shaded in red up above. The blue line is shading in blue down below. I'm looking for what part, it's like a Venn diagram, what part do they have in common? The part that they have in common is the purple part. So I might even whenever I go to write my solution, just say the purple is the solution. So if I pick any point on there, it would satisfy both equations. So for example, this point at 1, 0, 1, 0 would be one of infinitely many solutions to that system of linear inequalities. Okay? So, graphing a system of linear inequalities and solving it is another two-step process, and it's very, very simple. So step 1, you graph each of the inequalities in the system, and using your map pencils, your colored pencils, color the appropriate regions. Okay? Makes it kind of like a geography class. And then step 2, you're finding the region, you're identifying the region that they both have in common. Okay? This is the one that gets every single color. If I shade in red and I shade in blue, red plus blue equals purple. So I'm going to choose the purple as the answer. Okay? So let's try this on this system of equations, and you're going to see some award-winning animations going on right here. Okay, so I'm not going to graph these by hand, just going to animate it, but I expect you to graph this by hand. Go through it as I go through it so you get the practice, so you understand what's going on. Okay, so on the first one, I've got y is less than or equal to 3x plus 2. Okay, so I'm going to start at a y-intercept of 2, and then I'm going to use the slope of 3 to get a couple of more points, like so. So a y-intercept of 2, slope is up 3 and over 1, and then I draw my line. Is it a solid line or is it a dashed line? Well, it's a solid one because it's equal to. Okay, now I need to figure out what part of this I'm going to shade. Okay, so y is the line, and I want less than that line. See, it's less than, so I'm going to shade down below it. If that doesn't make any sense to you, come on, shade, there you go. You could always choose the origin, 0, 0, plug it into the equation and see if it's a true statement. If it is, I would shade that portion that contains the origin. If it's a false statement, shade the opposite portion. Okay. The next equation has a y-intercept of 4 and then a slope of -1. So I'm going to start at 4, go down 1, right 1. This one is a dashed line because it doesn't have an equal sign on it. Now, y, again, is the line, and we want greater than that, so it's going to shade upwards, like so. Okay? Again, you could pick 0, 0. If you pick 0, 0 on this one, let me just show you. I pick 0 is greater than -0 plus 4. Is 0 greater than 4? No, it's not. So I wouldn't shade the part with 0, 0. I'd shade up above the line instead. So my question is, what is the solution then? The solution to this system of inequalities is the green part. So the green equals the solution. And you have infinitely many of them. Get rid of that. So if I want just one solution that would work in both of those inequalities, how about, say, the point 5, 1? So 5, 1 would work in both of those inequalities, make them true. Okay? Let's try another one. So, graph the system of inequalities, and then if I look at the top one, it's kind of in standard form. I know it's an inequality. So let's, instead of doing it in y equals and slope-intercept, let's just use the two intercepts. The x-intercept, if I were to plug in 0 for y, I have 8 divided by 4, it's just 2. Okay? Now, the y-intercept, if I plug 0 in for x, 8 divided by 2 is positive 4. This is an equal sign, so it's going to be a solid line. On this one, you cannot go, oh, here's the line, and I'm going to shade up above the line because it's bigger than that, because y is not by itself. So I want to go back to the fallback method of plugging in 0, 0, 0, and seeing that's a true statement. So let's try that right here. So 4 times 0 plus 2 times 0, is that greater than or equal to 8? Well, that 0 is greater than or equal to 8. That is a false statement. So I do not shade the part with the origin. I have to shade the other part. I'm going to shade up above the line. Okay. Next one. This one is in slope-intercept form, so I'm going to start at a y-intercept of -3. and then I'm going to use the slope of -2, so I can either go down 2 and right 1 or up 2 and left 1. I think I did that. Instead, this is a dashed line because there's no equal sign on it. Oh, okay, so stop right here. Before we do our shading, our answer is going to totally depend on where this thing gets shaded, either below the line or up above the line. Okay, it's totally going to depend on that. So let's look at this. Y is by itself, so we can use the shortcut method. It's the line, and we want everything less than that, which is below the line. Here we go in yellow. Now look, I'm looking for where the two regions, the two colored parts, intersect each other, and they don't intersect anywhere, so this system has no solution. Now, if this yellow part was instead up above the line, then they would intersect everywhere in the blue region, and it would just be anything that satisfies the top equation would be the solution. But that's not what I have here. Okay, let's do one more of these together, and then I'll give you some to try on your own. This one, I'm going to throw in an absolute value. Whoa. Works the same way. Okay, so for the top equation, y is less than 2. If it was y is equal to 2, that would be a horizontal line that goes through 2. This one is a dashed one because it's not equal to, so let's just throw that horizontal dashed line in there. Y is the line, and we want everything less than that line, so this is going to go down below. Right? Ta-da! Okay, so the next one, it's an absolute value, so I'm expecting to get a V shape for this. Let's use the vertex method on it. Let's locate what the vertex is. The vertex is, this one lies to you. Liar. So it's a 1, comma, and I don't have anything at the end. There's no plus anything, so that y coordinate is 0. So the vertex is at 1, 0, so I'll put that as a point. In my A value, since there's nothing listed here, that's just an understood 1. So I'm going to go up 1, right 1 from the vertex, or up 1, left 1 to get the reflection point. This one is equal to, so it's going to get a solid line. And now let's determine where we're going to shade it. Y is the line, and we want everything greater than that, so we're going to shade up above, like so. So the region that represents the solution right here is the green stuff. So this green equals solution. And if I wanted a point that satisfies this, both the system here, I could just choose anything. How about I choose 1, 1? So the point 1, 1 would be an example of a solution, just one of infinitely many. So now it's your turn to try a couple of them. By a couple, I mean 3. So on your graph paper, go ahead and graph these. Have a little bit of fun with it by coloring them in. See what region that they have in common.